Hello, we are from Group 11, and let me introduce some of our group members. We have Amni, we have Afzal, we have Asyraf, we have Afiq, and me myself, Mohammed Daniel bin Mohammed Bachi. So for our project-based learning, we are going to present about CFRC, carbon. What is CFRC? CFRC is carbon fiber reinforced composite. This is popular in so many sectors, including and is exclusively popular in aviation sector. This is because this material is easily modified, lightweight, has increased specific strength, and having corrosion and chemical resistance. All these traits in one material is super awesome actually. So in aviation sector, CFRC provides numerous advantages over existing conventional material. So our objective is we seek to enhance the aerodynamic of airplane wings by using CFRC. So the question is, if we use CFRC, will it improve the aerodynamics of airplane wings? So we hypothesize that by using CFRC, the aerodynamics of aeroplane wings will improve drastically.
Hello, my name is Amni Wafiy bin Zaman, and today I'm going to talk about the consideration of method. So, the material for this project is carbon fiber reinforced composites, which is for short CFRC. But why are we talking about CFRC? Well, CFRC has a carbon-to-carbon bond with the unidirectional reinforcement fiber, which allows it to have the strength up to 700 megapascal and able to retain its feature above 2000 degrees Celsius. It also has heat resistance, chemical resistance, has a fluid tightness, and has an atmospheric resistance, excellent thermal shock resistance, and finally a lower density value, which is essential in the aviation wing fabrication sector. Now, we're going to look at the metrics of CFRC and the reinforcement used. So, CFRC is reinforced in the matrix of graphite. Then, phenolic resin combinations, petroleum, and coal tar pitches are also used to make the carbon matrices. Usually, CFRC is commonly infused with F584-epoxy matrix, which is able to improve the carbon fiber reinforcement capability. For the mechanical properties of CFRC, it has a compressive crushing strength of 240 megapascal, an elastic Young's tensile modulus of 95 gigapascal, Poisson's ratio of 0.32, a shear modulus of 36 gigapascal, and finally a tensile strength or the ultimate UTS for 19 megapascal.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asyraf and my student ID is 2100638. I'm going to explain about the method and the steps. So for epoxy matrix or nanofill resin, it's a combination of an epoxy precursor tetraglycidyl methylene dialene with a reactive diluent 1,3-butanediol diglycidyl ether, and they were combined or mixed with a ratio of 80 to 20 weight percentage respectively. And the curing agent for this epoxy matrix is a 4,4-diaminodiphenyl sulfone. Next one is a resin film infusion, and resin film infusion is used to manufacture CFRC by utilizing an unusual technology to infuse a nanofill resin into a carbon fiber dry perform, and the steps are as shown. First of all, a dry carbon fiber preform is placed in a vacuum bag. Next, the resin is injected from one edge of the preform while the vacuum is vented from the other, and this will allow the resin to flow the whole length of the preform. Thank you.
For the data collection of this project-based learning, for the performance of CFRC, which is also known as carbon fiber reinforced composite, it is intended for high performance and high cost application, used as the material for space shuttle nose cone and leading edges, employed in tokamak reactors as plasma phasing components, also known as the fusion technology, and suited for structural application, which are 1. Conducted at high temperature, 2. Required thermal shock resistance, and 3. Low coefficient of the thermal expansion. So for the cost of it, it is roughly about $21.5 per kilogram with a conversion efficiency of only 50%. And for the microstructure of CFRC, an optical microscope can accurately determine the number of filaments in the carbon fiber bundle, precursor carbon fiber features ribbon like shadow porous running longitudinally, and also carbon fiber with a higher modulus reveal the skin core structure more clearly.
Hello, my name is Mohammed Afzal bin Nordin, student ID 200000524. Okay. So today I will be present about data analysis and discussion for this project. In order for us to achieve the main objective, we need to relate some of the concepts in the material science that can be used to determine the effectiveness of CFRC towards aerodynamics. The first concept is about density. So we know that CFRC is a low density material which has enough mass to generate lift to overcome the airplane's weight. The second one is about stiffness. So stiffness is determined by the material's Young's modulus. By increasing in Young's modulus, it will be increasing in stiffness of a material. And we know that stiff materials is needed to avoid deformation of airplane wings. The third one is about tensile strength. So we know airplane wings will experience wind pressure. So we need a flexible material which can be recoverable under a huge amount of load. And CFRC are relatively stiff and strong. The last one is toughness. With a higher toughness means that it will be harder for airplane wings to break when exposed to high wind pressure during a bad weather.
So in conclusion for this project-based learning project, carbon fiber reinforced carbon, which is the CFRC, have a lot of the advantages and disadvantages. Using its advantages, and Afiq can be built because it is light, low dense, tough, stiff, and also strong. To make sure, and it is also to make sure that the wings of the aeroplane will not break apart when flying in the air. And CFRC is also suitable for the airplane wing. So this is for the our video presentation for project based learning from Group 11. Thank you very much.